Right, so what we have here is the actual Dreadnought model itself, and that's its weapon arm, just there. Okay. Now first of all we need to look at this in a very, very basic manner, so I'm just going to get out my old trusty pen. What we have is a very simple barrel here, which presumably would hold gears and things like that. At the end we then have this, which is a power fist with fingers. Now over here what we have is a kind of elbow unit. Okay, and then leading off from the elbow unit would presumably have some sort of a larger internal kind of wheel here, which would mount it to the top, just there, and would allow for a degree of rotation that way. Now then, I'm not actually seeing too much about that, and if you remember, we've got this kind of flap on our arm. If we just kind of quickly sketch out the rough shape of it. We do have this kind of flap piece coming down here. Yeah. So, then decide whether or not we keep that later on, because we do need the revolving, the rotating mechanism to allow more movement in the actual arm. Okay, and we'll swap over pens now. So let's look at this middle part here. That's quite an important part. This small area here basically is the most important part of our entire arm. So what we have is, I'll move that to there. We have our round central area here, okay, which we're going to have a main piston come out of down here, which will connect to the back of our power fist. Yeah, that's our power fist there. Drawn a few minor detail lines. It's very loose, very rough. Don't worry about that. That's the style I want to have. Okay, now what we're going to have is redundant detail. So come up like that and like that. Secondary pipe work coming down here and down here. And yes, it's supposed to be loose like this. Then we'll come off the sides of this mount here. In the middle here we'll have some superfluous detail, masses of rivets, whatever. Okay, now at the back of this we have to find out how this is going to attach to our rotating part here, which is going to fit underneath. Now the simplest way of having a rotation is to have a pipe that would come down like that and then bolt this part onto the side of it here. But we also have to take into account that this is going to be rotating this way as well as this way. So we have to think carefully on exactly what we're going to do to make that work. Let's move that up here. Now if we have, I've got a pen in my mouth, which is why I'm talking like that. I'm going to switch down to a thin pen now, again. If we have this overall shape, which is basically this, comes up to here and here, okay. So we're going to have this shape here, build a mount, attaches onto it, that has our main kind of shock absorbing piston coming down here, yeah, like that. Then we have our two control arms coming off it by whatever means we fancy, that connects onto here and onto here. Okay, so now we can move this plate here this way and this way, yeah, which would give us a kind of interesting range of movement really when you think about it, when this is supposed to be the elbow. We don't want too much movement there, but it will give us a lot more movement than we would have already had. And bear in mind that this part here at the back is going to be quite covered by this part in a way, so you won't see this bit here. Okay, so this part here is going to be, we'll still model it. Okay, so this part here, if we consider, isn't going to be at this angle, it's going to be at this angle. Up here we have the top, okay, where we have our, presumably our drive shafts and engine blocks and things. So if this is overall our main cylinder, that's going to come down here. It's going to allow rotation. We want rotation, but we also want movement on this piece here. Now we need it to be able to come up quite high and come down quite low. And if we've got these pieces here and here, okay, they're going to block the movement coming this way and this way. So we have to think logically how we're going to get around that. Now we've got a couple of choices, but I think the best one is to have basically what would look like a gear, but isn't. It's basically a fake gear. So we have a secondary disc behind it here, and perhaps inside the disc we can make cutouts or whatever we want here. Make it look like, you know, they're trying to save weight. Holy icons, skulls, whatever the hell you want. So we've got that part there, yeah? If we make it a slightly more intriguing kind of large piece here, we can then drive this down. Now the problem we've got is that we don't want to literally have this welded on one side. What I mean by that is, let's say we've got our one disc here, okay? And this isn't the greatest picture of it in the world, but bear with me. So we've got our disc here, yeah? I know it's a crappy picture. And then here, you've got basically that part there, coming out a bit. Yeah. And then on top of that, you've got these parts there. And this part here, yeah? Now if you just have that on one side, that's not going to look balanced particularly, is it? Which is always a problem. But we don't have to think, well, why have it on one side when we can have it on both sides? So, simplest thing to do is have this wheel here, make it a bit wider, give it a bit of a recess. There, that way we can have this part connecting into it. And then on the other side, have it again. So rather than having 3 pistons controlling the power fist, which is cool, instead we have 6 pistons controlling the power fist, which makes it even more powerful. And then have them, rather than having them coming in a top-down view, so we would have, this is basically our, that's that piece, and then off the top of that we have this piece here, and this piece here. And rather than having the pistons come straight forward there and there, we can actually have them come at a slight angle as well, which will give it a more dynamic look to it, yeah? So then all we need to do, really, is bring down, because most of this part's hidden anyway, we then bring down this part here into this, pardon me, and we can build some sort of interesting shaped piece to kind of lock into that. If that's round and we have a straight tube coming into it, we've got a couple of methods of things we can do. Depending on how wide the tube is, we're not going to see much of the tube, if anything. So bring it to an end and then just build a standard Eggman shape. Just come straight down into that. Make that an off shape as well, maybe something like that. So there, and that'll give it slightly more movement out the front, as it were. Okay. So let's look at what our movements, our angles of movement are. Now we started obviously with the rough picture of what we're going to be doing. Got onto this and this, and these are not concept drawings. We don't have to worry about concept art. We know what it's going to look like at the end. This is a kind of logistical design of what the movements and range of movements we can get out of it will be if we design it more logically. Okay, next. Just really thinking for a second then. If we look at the movement, we have up, down, which is good. We have the rotation there, which is good. We can have an in-out swing just by adding a second bar there, which is fine. And by in-out swing, what I mean is if we bring that up there off the big pole, we can basically build a simple rotating crossbar in there that will allow this to swing out and in, out and in, if we want to. In that case, it will be linked to the movement of the flap. This has movement in all 4 axes, just for, you know, positioning it slightly more. We get rotation off the end, and a standard wrist movement. I'll add some minor movement in as well. Perhaps use pistons, or perhaps just hide it as a cuff. for the fingers of the actual power fist, and then at the very end we have flex movement on the fingers, and inside a burner and underneath big gun. And we'll connect that up to there and it will be lovely. Okay, so I hope that's kind of explained to you some of the logistical processes involved in breaking down the arm and how it's going to work. Now what we have to do is translate this into 3D.